myself Heming Satvara, and I am working from LG Institute of Engineering and Technology. So today we are going to discuss about one more new sensor which is known as LM35 sensor. Now in this project we are going to interface LM35 sensor with the Arduino Uno R3. So here you can see the project outlines. First we will discuss about components which is going to be used in this project, then how LM35 sensor works, after that system layouts and program along with actual representation in software. So let us start with components. So here you can see this is Arduino Uno R3 pin diagram. So this is basically heart of this IoT project. First of all, we are going to connect USB plug. Here you can see this is USB plug with laptop. Then we need to energize this Atmega 328 microcontroller. Above side you can see it is digital input pins, and below one it is analog input pins, which are the 6 total pins. And here you can see here most of 14 pins are there. Now here you can see 5 volt power pin and 3.3 volt power pin is also available. Here it is the LM35 sensor. At the first looking, many people get confused between LM35 sensor and transistor. It is look like a transistor, but it is not. Here you can see this is LM35 sensor, in which 3 legs are there or 3 pins are there. First pin, it is for voltage, or precisely we can say it is VCC, where we are going to connect power supply 4 to 20 volt. Then middle one, it is for out, that is basically your output terminal. And last one, this is your ground, G and D. So like this we are going to connect LM35 sensor with this Arduino board Uno R3. So what is LM35 sensor and how LM35 sensor works? LM35 sensor uses a basic principle of diode, whereas temperature increases, the voltage across a diode increases at a known rate. So basically it is sensing the temperature around this sensor. When your temperature increases, voltage across this diode increases like this. In order to understand the working principle of M, we have to understand linear scale factor. So in this picture of LM35, it gives to be plus 10 millivolt per degree centigrade, degree Celsius. That means with increase in output of 10 millivolt by the sensor, your Vout pin, the temperature value increases by 1. So here we can see, for example, here is the example. If sensor's output is 100 millivolt, at this time your output will be shows you 10 degree Celsius. So in another word, I can say the same goes to the negative temperature reading. For example, if your output will be minus 100 millivolt, at this time your temperature will be minus 10 degree Celsius. So basically here you have to understand it is 10 millivolt per degree Celsius. So like this your LM35 sensor will be work. Here is the system layout in which we are going to connect LM35 sensor, which is basically our input port. Then we are going to interface with this Arduino R3 board, Arduino Uno R3 board. Then we are going to connect with this virtual terminal. I already told you that virtual terminal that send the data to the serial port and receive the data from the serial port. So here that's why this arrow indication is both sides like this. Send and receive the data from the serial port. So here it is the virtual terminal. Now this is the program for LM35 sensor. Now here we have to define few functions like temperature pin A0. Now here we are using analog port, that's why it is A0, analog 0. Integer temperature value, void setup, serial dot begin 96,000, because we have to initializing this serial port at 96,000 bps. Void loop, temperature value is equal to analog read. Now we have to remember this, it is analog port, so you have to apply analog read function instead of digital read, right? Temperature pin, because we get LM35 value and save it in variable. Float temperature Celsius is equal to, it is basically equation to getting the Celsius value from 10-bit analog value. That's why we have to apply temperature value, which is already here. You can see temperature value is equal to analog read in bracket temperature pin. So temperature Celsius is equal to temperature value divided by 1023.0 into 100. So basically this is the equation to getting the Celsius value from 10-bit analog value. Float temperature Fahrenheit. So FARH, it is for the Fahrenheit, is equal to temperature Celsius into 9 outside bracket divided by 5 plus 35. So we need to convert this Celsius value into this Fahrenheit. That's why we have to apply this equation. Then serial dot print in bracket temperature in Celsius. So it shows you, it displays you temperature in Celsius. Serial dot print temperature Celsius, serial dot print C, that is basically for the Celsius. Serial dot print, which we are going to use to separate two different temperature in Celsius and Fahrenheit. Serial dot print temperature is equal to serial dot print to print temperature in Fahrenheit. That's why we have to use F. Serial dot print ln and delay 1000. So here this is the program for the LM35 sensor. Here you can see this is the final project of LM35 on Proteus software. So first we need to use Arduino board. Here you can see this is Arduino board, ARD. So how to connect this pin numbers? So for that you have to remember your program. Here you can see, here you are applying A0 temperature pin. So it must be on A0. As I told you earlier in this session, there are 3 different pins like this. Here you can see, this is your sensor, 1, 2 and 3 pins. First pin for VCC, second pin for out and third pin for GND. So center one is for the out. So here you can see this is center one, it is for the out. Now we define already your temperature pin, which is at A0. That's why here you can see it is directly connected to this A0. Here it is A0. So here it is A0 pin. Now third one, it is ground. So it is grounded, and here we are going to apply VCC. So like this you have to connect this LM35 sensor with this Arduino board Uno. Then after we have to display values of Celsius and Fahrenheit, values of temperature. For that you have to connect virtual terminal. So basically here we are going to connect virtual terminal. So this is basically virtual terminal. For that you have to connect this RXD port on 1 number pin. So remember this thing, in whatever you are programming, in whatever project you are using virtual terminal, at this time RXD you can connect on pin number 1. So here this is the LM35 project on Proteus. Now I give you live demonstration of LM35 project in Proteus. So here you can see this is the software, this is the Proteus software in which we are going to connect like this. So first I told you already, for that you have to use program, or you have to load this program into this microcontroller 328. So you have to double click on this Arduino board like this. So here it is the location of that link. So here is the program which we discussed earlier in presentation. So just we have to verify first, is it right or wrong? For that you have to click on this right button. So it is going to be verified. If there is an error, so it shows you in red sentences. That means in your program there is an error. So it is basically compiling all the program and reading these functions. So here you can see it is already verified. So now you just have to click on this link. You just need to select this path location and paste it on this Arduino board. You just need to paste it here and click on OK button. That means it indicates your program is uploaded on this Atmega 328 microcontroller. So now you can run this program. So here you can see the value of temperature in Celsius, which is going to convert in temperature in Fahrenheit. But you can change the temperature from here. This is +1 and this is minus button. So here if I am going to increase this temperature around this sensor, so you can note down this values: 25.42 Celsius, then its Fahrenheit is 77.75. So again I am going to increase values of temperature. So here you can see 30.79 Celsius and its Fahrenheit is 87.43. Like this you can change the sensor temperature through this software. Well, in actual interfacing with this LM35 and Arduino board, at this time it senses the temperature surrounding atmosphere. So it is going to be measure that particular temperature in Celsius and it convert into the Fahrenheit. So here you can see this is the actual LM35 project, but in this case we are using breadboard. Here you can see this is breadboard. On this breadboard we have to place this LM35 sensor and just have to connect this wires to this Arduino board. So first I told you this is VCC. First pin is VCC, second one is for the out, and last one is for the ground. So ground wire it is here. So here you can see in breadboard this line is serially connected like this, right? So here we insert pin over here and here we can connect one wire, or it is also known as jumper wire, through ground. Plus 5 voltage it is connected to the VCC and output it is connected to the A0. Whatever you are defining in the start, in the beginning of the program, you need to just connect that particular wire to the V out.
So here you can see this is the interfacing of LM35 sensor. Here it is, which is connected interface with this Arduino Uno board. Now it senses the temperature. Here you can see it shows temperature reading over here. It is around 24.41, and now whenever I am putting my hand over here like this, so it senses little bit more temperature. So you can see here it is going to be increased like this. So here you can see there are 3 pins, one for the ground, one center one for the out, and last one for the VCC. So starting from black color, here you can see black color, which is your ground, which is going to the ground connection. Orange pin, which is in center, that is basically V out. So here it is going to A0, and last one, red one, which is VCC, it is 5 voltage. So it is here. So like this you can sense the temperature over here in system monitor. Thank you.
So that's it for today's session. Thank you.